and welcome to Conversations with Matt DeLockery. In the last two episodes, we've looked at three different reasons to think that the universe began to exist. There were two philosophical reasons based on the nature of infinity, and one scientific reason based on the second law of thermodynamics. In this episode, we're going to look at the fourth and final reason to think that the universe began to exist. It's also going to come from science, and it has to do with how scientists think that the universe actually came into being. So, let's dial the clock back about 100 years to the beginning of the 20th century. Pretty commonly, it was believed that the universe had just always been there. It was eternally old. Things in it moved and changed, but the universe itself didn't. Primarily, the people who were saying that the universe had a beginning were religious people, like Jews and Christians. That whole, in the beginning, God created the heavens and the earth thing. Things continued like that for a long time, in a relatively stable way, and then Einstein showed up. In 1917, Einstein proposed his general theory of relativity, and this is really when things started to change. His theory predicted a universe that was either expanding or collapsing, rather than one that was staying still in this sort of static, eternal existence that most people believed in. The problem with this was that if the universe isn't stable, if it were expanding like Einstein's theory seemed to indicate, then the idea of an eternal and stable universe would have to be done away with. This was a time when things really started to change. Between 1922 and 1924, the Soviet mathematician Alexander Friedmann took Einstein's equations and derived the results that would predict an expanding universe. Unfortunately, he died in 1925, and nobody realized what he had found until later. However, in 1927, the Belgian priest, astronomer, and professor Georges Lemaitre independently arrived at similar results to Friedmann. 2 years after Lemaitre had done his work on paper, Edwin Hubble showed up. You know, the guy the Hubble telescope is named for. In 1929, Hubble published a paper correlating the relation between a galaxy's distance and something known as redshift. Basically what happens is that things like stars that are moving away from us very quickly look more red than they should. They have a red tint to them. Things like stars that are moving towards us very quickly look more blue than they should. They have a blue tint to them. I've linked to a video in the description that explains what redshift is in more detail for those who don't know. It's easier to see it with a video than for me to explain it with only audio, so check out that video. What Hubble noticed is that the farther galaxies were apart from each other, the faster they were moving away from each other. Basically, that meant that just about everything in the universe was, and is, moving away from each other. So if everything is moving away from each other as we go forward in time, what happens when we wind the clock back? If we were to wind the clock back, then everything would get closer together. What we see then is an expanding universe. Of course, if the universe is expanding, then the thinking goes, it cannot have been expanding forever. There must have been a beginning. We'll get to arguments about that in the next episode. Anyway, this is why models of the universe we see today are often represented with something that looks like a cone. The width of the cone represents the size of the universe. The big end is now, because the universe is very large. The small end was a long time ago and is its beginning. What Hubble discovered pointed towards this same thing. Of course, not everyone liked the idea of the Big Bang. Einstein was one of those people who assumed a static universe being a universe that is neither expanding nor contracting. Because of this, when his own equations seemed to indicate that the universe was not static, he introduced the cosmological constant to allow the universe to remain static. However, after Hubble discovered the stuff that we just talked about with the redshifts, Einstein abandoned the static model in favor of expanding models. Sir Fred Hoyle was another person who did not like the idea of an expanding universe, or more specifically, an expanding universe that had a beginning. So this is not the Hoyle from the phrase, according to Hoyle, referring to the correct rules and play of card games. That was Edmund Hoyle, about 250 years earlier. I have no idea if they're related. Anyway, Sir Fred Hoyle was a proponent of the steady-state theory, which is a theory about a static universe. He disliked the idea of the universe having a beginning and thought it was pseudoscience. He thought that the only reason scientists liked the Big Bang is because they believed in the book of Genesis. In the beginning God created the heavens and the earth. Think about that for a moment. People today think that the Big Bang Theory is an argument against theism in general, and often Christianity in particular. But back when the Big Bang Theory first came out, people disliked it because it sounded too much like theism in general and Christianity in particular. I suggest that the only reason anyone gets away with this today is because most theists don't know arguments like the one we're talking about right now. Once someone agrees that the universe had a beginning, all you need for them to agree to is cause and effect, and you've got the universe needing a cause. In the last episode of this series, we'll talk about what sorts of attributes that cause has. In other words, based on what we know about the Big Bang Theory, what must that cause be like? Anyway, back to Hoyle. So, not only did Hoyle dislike the Big Bang Theory because it sounded too much like Genesis, he was also the person who coined the phrase, the Big Bang Theory. Now, he argued that he didn't mean the phrase to be insulting, just merely descriptive. However, other scientists argued that he actually did mean it to be an insult to those who held the view. Which is correct is another issue. But, so you know, that's where the name came from. We'll talk about Hoyle's steady-state theory when we look at alternative models to the Big Bang Theory in the next episode. For now, let's get back to the Big Bang Theory and look at additional evidence. Now, there are a few other reasons to think that the Big Bang actually happened, besides Einstein's general relativity equations and Hubble's redshift. I'm going to explain them as best I can, but as you should know by now, I'm not a scientist. If I get something wrong, which I might, or if I could have explained it better, which I almost certainly could have, please don't hate me. Maybe just view this as a place to start, so that you can go look the information up for yourself and get it right. Anyway, here goes. Another reason to think that the Big Bang actually happened is something called cosmic microwave background radiation. This was discovered in 1964 by Arno Penzias and Robert Wilson. The cosmic microwave background radiation is basically the leftovers of something that would have happened as a result of the Big Bang. The fact that we see it now provides evidence to think that the Big Bang actually happened. So, what is it? As I understand it, what happened was that way back at the beginning, everything most of us learned in high school science classes was a bit different. And the farther back in time you go, the more different it was. For example, we learned in high school chemistry class that protons exist in the center of atoms and electrons spin around the outside. Well, the Big Bang Theory predicts that way back in time, when the universe was a lot hotter, this wasn't the case. While everything was still pretty hot, protons and electrons moved around freely in a sort of super hot fog. As the universe expanded, everything cooled down, which allowed the protons and electrons to form into atoms, specifically hydrogen atoms. So keep that in your head for a minute because I need to add one more layer to this explanation. And don't worry, it'll only be one more layer. So when everything was hot, protons and electrons moved around freely. When everything cooled, they formed atoms. Now what's interesting is that when the protons and electrons were moving around freely, there was light. But you really wouldn't have been able to see much of it back then. With all the protons and electrons moving around, the light wouldn't get very far before it would hit something and bounce off. Basically, the light was stuck in a cosmic pinball game, and so you couldn't see very far. Unlike today, where we can use telescopes to look across the universe. You couldn't have done that back then. However, when the universe cooled off enough, the protons and electrons combined to form atoms, and there was no longer this fog. Light suddenly became able to travel freely around the universe. This light is what the cosmic microwave background radiation is. The reason we can't see it, though, is because as the universe has expanded, its wavelength has increased. So, whereas the light used to be in the visible spectrum, and the universe would have looked orange, yes, it actually looked orange rather than black, now it's a much longer wavelength, and our eyes can't see it. But it can be picked up with a radio telescope, which is what Arno Penzias and Robert Wilson did. The neat thing is that this microwave radiation gives scientists a sort of picture, if you will, of what the universe looked like back then. And they measure small variations in it to understand how the universe has developed over time. But the fact is that this radiation provides evidence that the Big Bang actually happened. Okay, so there's a look at another line of evidence that points towards the Big Bang actually happening. I want to point out that there are more, but I'm not going to go over every single one of them. If you're interested in this topic and want to go further, you might want to look into the other lines of evidence. What is important about all of this is that if the Big Bang actually happened, then there is a beginning to the universe. And if you remember how this argument works, that's what we're really focusing on. To review the argument again, it goes like this. 1. Whatever begins to exist has a cause. 2. The universe began to exist. 3. Therefore, the universe had a cause. The first episode in this series focused on the first premise, which, if you remember, was basically just cause and effect. Everything else we've done since then has been focused on the second premise, that the universe began to exist. Now, we have seen 2 philosophical and 2 scientific arguments, all of which suggest that the universe began to exist. The Big Bang Theory is the second of the scientific arguments. There are 2 episodes left in this series. In the next episode, we're going to take a look at other potential models of the universe to see if there's a better option to the Big Bang Theory. Or, more specifically, we're going to try to figure out whether there's another option that might suggest that the universe didn't have a beginning. In the last episode, we're going to get to the conclusion and look at this cause that the universe seems to have. What is it? What can we know about it? Is it a god, or is it something else? So stick around for the last 2 episodes as we finish working our way to the conclusion. And for those of you who have been listening for a while, if you wouldn't mind, please leave a rating and think about writing a review. It'll let people who come across this podcast know whether it's for them or not. And if you haven't been listening that long, subscribe to this podcast, if you enjoy it, that is. If not, no worries. I hope you find what you're looking for. Either way, thanks for listening, and I'll talk to you next time.